Welcome everyone. In this video series, we are going to look at continuity and limits involving infinity. And so you can see the different learning objectives and the different videos that you're going to be watching as a part of this video series. We're going to dive right in and talk about continuity, and we're going to start right off with the definition. So a function is continuous if at a point, right, we have the limit of that function as x approaches that point to be equal to f of a. So just whatever the function evaluated at that particular point is. And so just to be clear, when we use this definition, we have to have a few things true. We have to have that f of a is defined. Okay, so it exists, right? We have to have the limit as x approaches a of f of x, that needs to exist. And therefore, if the limit exists, remember that the left, or the right, I should say, the right and left-hand limits at that point exist and are equal. Okay, and then finally, it's not only that the limits exist, it's that truly that the limit as x approaches a of f of x is the same value as whatever f of a is. So all of that is embedded in this one definition, so beware. And so now that's sort of the technical definition, but more intuitively, when we think about what a continuous function should look like at a point, it should be an unbroken curve. And so you can really just draw it without lifting your pencil, okay? And so something that would be continuous at a certain point, okay, so let's say here is a, right? Let's say here is our curve, okay? Something like that. It looks kind of sinusoidal. Maybe it is, maybe it isn't. But either way, we can trace up, find that function value, okay, call that f of a, and then notice that as we come in from the right, and I should maybe make that a little bit clearer, and as we come in from the left, right, the limit would agree with that, okay? Something that would not be continuous, and let's mark a again on here. Okay, here's a. Something that would not be continuous would be something like, okay, we have this, and then we have a dot here, and then we continue on like that. Okay, so here we can see that as we come in from the left-hand side, it is one value of y, and then as we come in from the right, it's another value of y, and here would be f of a. So the limit doesn't exist, f of a is defined, but the limits at a doesn't exist, okay? And so if we're in that second case where we, see that the values, that the function is not continuous, or rather, something's wrong, either the left and right hand limits disagree, the function isn't defined, right? Then we would say that the function is discontinuous, right? Or it has a discontinuity at a. All right, and so that is a quick introduction to the concept of continuity, or also its counterpart, discontinuity. And in the next video, we'll look at discontinuity a bit further.